Hey guys, let's talk about elements, compounds, and mixtures today in our notes. Today we are essential question, and what we're going to be talking about is how is matter classified based on its composition. So every substance around us is made up of something, right? It's composed of something. So how can we classify and define things based on how they're put together, what they're made up of? Topic question number 1. Let's review and talk about what is matter. Remember, we said matter is anything that has mass and takes up space. Anything that we can measure the mass of and measure the volume of, that is matter. I just want to remind you these do activities. Wherever you see an arrow that says do, these we're going to do together in class when we process our notes. So you can go ahead and skip the pictures and the instructions right now. We'll do that together in class. Topic question number 2. What is a pure substance? How do we define a pure substance? Well, a pure substance is made of the same material throughout, and it has the same properties throughout the entire sample. So when we're talking about properties, we're talking about physical properties, but also chemical properties. And again, we'll list some physical and chemical properties of matter together in class. But remember, in a pure substance, you're going to have a sample that has the same physical and chemical properties throughout the whole sample. A good way to decide if something is a pure substance or not is to pretend like you're holding it in your hands. Then you can ask yourself, what you have in your hands, is it made of just one kind of substance? Is it all made of the same thing, or can you see or detect different things in that sample in your hand? Topic question number 3. What is the simplest form of pure matter? The simplest form of pure matter is something we call an element. Elements are the purest form of matter. They cannot be broken down further beyond their own composition. And any amount of a pure element retains the unique physical and chemical properties of that element. So a pure element has just the physical and chemical properties of that particular element. It's just composed of one type of element. Well, how do we know which are the elements? A great way is to go ahead and look at the periodic table. There are 118 elements, and they're all represented on the periodic table. When we're representing these elements, we use chemical symbols. Chemical symbols are written with 1 or 2 letters, but only the first letter is capitalized. So you can see over here, we've got the capital letter C, that stands for carbon. But then up here, we've got the capital letter C followed by lowercase a, that's calcium, okay? So we either have 1 letter or 2 letters, but only the first letter is capitalized. Again, we'll do our do activity together in class. Topic question number 4. What is a diatomic element? So I've told you that elements are pure. And so when we're talking about elements, we're talking about a sample that only has one type of atom in it, only one type of element in it throughout the whole sample. But we can also have diatomic elements. Diatomic means there are 2 atoms bonded together. Notice here in this diatomic element of iodine, we've got 2 iodine molecules that are chemically bonded together. That's a diatomic element because in its pure form, there's nothing here but iodine, it's always bonded to itself, kind of like twins that are always together, right? Some of the atoms in the periodic table are just more stable when they're chemically bonded to themselves. And there are 7 of these diatomic elements. But notice, we're still just talking about one type of atom, okay? Whenever we're talking about an element, we're just talking about one type of atom throughout the entire sample. And again, we'll talk more about which There are seven different types of diatomic elements. We'll identify those in class. Moving on to topic question number 5. What is matter that is composed of more than one element? What happens when you see more than one type of element in your sample? We call those compounds. Compounds are still pure substances, but they're made of two or more elements that are chemically bonded together. A compound has different properties than the individual elements that are in it. When you have a compound, you have a sample that has totally different properties than the elements that make it up because they're chemically bonded. Something to remember is energy must be taken in or given off when a compound is broken apart or put together, right? We've got different types of atoms in that compound, and in order to break those chemical bonds, energy must be taken in or given off. Separating the elements in a compound requires a chemical reaction. Remember, we have already talked about some things that indicate that a chemical reaction is happening in a beaker, right? When we did our reaction in a baggie, we talked about some of the signs of a chemical reaction. Maybe we give off a gas or an odor. Maybe there's a temperature change or there's a color change. Those types of things indicate that that might be a chemical reaction. The way that we show compounds is we use chemical symbols, but because there's more than one element, we combine them into something called chemical formulas. Chemical formulas represent how many atoms of each element are part of the compound. So for example, if we look over here at CO2, CO2 is representing carbon dioxide. We can see that there's one carbon atom, and this subscript 2 tells us there's 2 oxygen atoms for every molecule in our compound here, in carbon dioxide. They're in this fixed ratio, right? Still a pure substance. If we had a sample of pure carbon dioxide, we would know for every 1 carbon atom, it would be chemically bonded to 2 oxygen atoms. Over here, when we look at calcium carbonate, we can see that we've got 1 calcium atom. Notice there's no 1 written here. That's just sort of understood. If you just see 1 chemical symbol for calcium, we're talking about 1 atom. Here there's one capital C for carbon, so 1 carbon atom, and then this subscript 3 tells us there's 3 oxygen atoms. So in the compound calcium carbonate, we've got 1 calcium atom and 1 carbon atom for every 3 oxygen atoms. Again, we're going to talk more about these different chemical formulas and label them. So we'll do this together in class. You can fill out, though, we've got H2O representing water, C6H12O6 representing sugar, NaHCO3, which we've used in class already, that's baking soda, and NaCl, which is table salt. Let's move on to topic question number 6. What is matter that is composed of more than one substance? That's what we call a mixture. Mixtures are not pure substances. Their parts are not chemically combined. They're only physically combined. They're just mixed together. How can we tell if they're chemically combined, and how can we tell if they're physically combined? Well, when substances are combined into a mixture, they keep their own properties because a new substance has not been formed. For example, when we were looking at the salad on this slide, you can tell if we've got lettuce and peas and tomatoes and croutons, when we mix them up into a salad, we're not creating some new chemical with its own properties. We still have tomatoes that act like tomatoes, lettuce that tastes like tomatoes, peas and croutons that taste like croutons. They retain their own properties. We have not created something new. We've just physically mixed several substances together. We break down mixtures a little farther. Okay, so we talk about two different types of mixtures. We've got homogeneous mixtures. You can say homogeneous or homogeneous mixtures, like homogeneous milk, or heterogeneous mixtures. Remember, when we say homo, that means the same. Hetero means different. Let's talk about homogeneous mixtures first. In homogeneous mixtures, the parts are evenly mixed and they stay evenly mixed. So all the different substances are uniformly distributed throughout the entire mixture. Homogeneous mixtures are also known as solutions. Air is a solution of gases. We know that there's nitrogen, oxygen, carbon dioxide, maybe even a little water vapor in air. All of those gases retain their own unique properties, but they are uniformly mixed together to create air. In iced tea, you've got sugar and water uniformly distributed throughout the entire substance. And then in an instrument made of brass, you've got two different metals, copper and zinc, uniformly distributed so that when you look at it, the mixture looks homogeneous. It all looks the same, but we know that we have two different metals, two different substances uniformly distributed to make one mixture. In heterogeneous mixtures, it's a little different. The parts of a heterogeneous mixture are not evenly mixed. So some examples of some heterogeneous mixtures are something like soup, where you've got little chopped up vegetables mixed in broth. You could consider that a suspension, or something like ketchup is a suspension. In a suspension, the particles can settle and form layers over time. Eventually, these heterogeneous mixtures, they're not uniformly distributed. So over time, some of the parts of the mixture can settle out, and you can see the different parts of the mixture. Again, in colloids, something like 2% milk, sometimes you can see the different particles. It looks almost like a homogeneous mixture, but if you look through a beam of light, you can see the difference in the different types of particles. And that would be considered a colloid. Those are our different types of mixtures. Topic question 7. Again, you just need to fill out the topic question. We'll go ahead and complete this Venn diagram together in class, okay? But we're going to be thinking about what are the similarities and the differences between elements, compounds, and mixtures. So just like we did with our states of matter, how are compounds distinct, different from mixtures, and then what do they have in common? How are elements and compounds distinct? How are they different? But then what do they have in common? Okay, so we'll do that together in class. If you want more background or more information on the differences between elements, compounds, and mixtures, go ahead to the bottom of the module in this for this topic, and you can watch the video on elements, compounds, and mixtures, or you can review the extra information in the extra slide deck attached below. Thanks very much. See you in class.